Another type of function that we want to master is the exponential function. An exponential function has the form a times b raised to the x, where b is a number. Be careful, it is easy to get exponential functions and power functions mixed up. Exponential functions have a variable, such as x, in the exponent, while power functions have a variable, such as x, in the base. If we have b raised to the x, the indefinite integral is 1 over natural log of b times b to the x. We will talk about why this rule is what it is in another video, but for now let's see how it can be applied. First, let's look at a basic application. What is the indefinite integral of 3 to the x? This is pattern matching. The b in the base here is 3, so the indefinite integral is 1 over natural log of 3 times 3 raised to the x. A second example is a special case that deserves special consideration. What is the indefinite integral of e raised to the x? Applying the rule gives 1 over natural log of e times e to the x. You won't usually see it written that way, however. Natural log of e is equal to 1, so this could be 1 over 1 times e to the x, or just e to the x. Often it's helpful to know basic algebraic rules for rewriting expressions to make sure we can get things in a format that works. Let's look at the indefinite integral of 2 raised to the negative x power. We can't apply the exponential indefinite integral rule directly, because our rule involves a positive exponent and our expression doesn't have one. Instead, we need to rewrite 2 to the negative x as 2 raised to the negative 1, raised to the x. This way it fits the pattern that we have for the indefinite integral with b equals 2 to the negative 1. Applying the rule gives 1 over natural log of 2 raised to the negative 1 times 2 raised to the negative 1 raised to the x. You're likely to see this written in other equivalent ways. One way that you might see this is as negative 1 over natural log of 2 times 2 raised to the negative x. The negative sign in front comes from applying a property of natural logs that says natural log of c raised to the d power is equivalent to d times natural log of c. We're pulling that negative 1 out of the natural log using this property. And 2 to the negative 1 raised to the x is equivalent to 2 raised to the negative x using algebraic properties of powers. Here is another question where we can use exponential rule, even if it isn't obvious at first. Here we are asked to find the indefinite integral of 2 to the x over 9 to the x dx. The key insight is that we can use algebraic properties of exponents to rewrite this as 2 over 9 raised to the x. This is now a straightforward exponential rule problem, since we have b raised to the x with b equals 2 over 9. The resulting indefinite integral is 1 over natural log of 2 over 9 times the fraction 2 over 9 raised to the x power plus c. You might see the denominator natural log of 2 over 9 rewritten as natural log of 2 minus natural log of 9. This is a property of natural logs. It is rare to see natural log of a fraction. Usually this property is used.